And another major operation of stack pop, opposite of a push. So let's define pop function. We are going to change the p top so it cannot be constant. And then here in void istack pop function. First, if any application tries to pop when stack is empty, that's a logic error. So let's keep from happening. So it should not be empty. That's the precondition. And then assert function is defined in C assert library. So let's include that. Then how do we implement the pop function? Let me draw some picture. So I define stack object S1, then S1 object is created, P top is a null pointer. Now if I do push, then a node structure is created, data is stored, link member is initially null pointer, then p top should point to the new one just entered. So if we have only one node in stack, then pop means remove the existing one, and then p top becomes a null pointer again. So let's consider that. So if the istack has only one node, how do we know that? Pop. So one node data only is if p top is null is taken care. It should not be empty. So p top is pointing to the node, and then link, we come down here, is null ptr, then that's only one node data. So it's one node only is there. In that case, we can simply have the p top to null. Then this memory was dynamically created. Remember, when you do push, we created a node structure dynamically. So we no longer use this one. We need to free the memory. So delete p top. Then this memory is freed, and then p top becomes a null ptr. That's when we have only one node. That's the condition. Otherwise, then we have more than one node. So let's consider that situation. See if I have s1 dot push the data 6, then node is created, data 6 is stored, initially null pointer, but push operation that this new node points to the one that was on the top of the stack. Now p top is pointing to the new one, just one. So at this moment, if I do pop, this guy, always the one on the top of the stack should be removed. Removing this one means the p top is bypassing the top of the stack, blue one, and then pointing second one by skipping this one. That's a pop operation. But a few things we need to consider is that since this one was dynamically allocated, so we need to free the memory once direct bypassing link is set up. So what value should be stored in p top? That is the address of skipping one. Then where is the address of this guy? Address of this one is here. How do I get here? Before you change p top arrow link is the value here that is pointing to the second one. So the basic operation would be something like this. So bypassing to the next one is a p top becomes a p top arrow link. Then that's how to set a bypass. Bypass top of the stack. So p top value, so current p top arrow link. This value is the address of this guy. So we set up this green arrow by doing that. If we do so, the problem is we have lost the address of the top of the stack, the blue one, so we are unable to free this memory. So prior to update ptop, we may need to save the address of the blue one so that we can free the memory after updating the ptop. So idea is we can create a pointer where I want to store current ptop, that is a blue one, and then we update the bypass link, and then we free the memory. So that's the right order of execution, so that we can free the memory after the setting up the bypass link. So that's what you need to do to implement the pop operation.